Alright folks, and welcome back to another video. So today is going to be the first video in the educational series on the channel, and I'm starting with engineering mathematics. Now, engineering mathematics usually at university level starts with polynomials and linear equations. For purposes of this video, I'm going to be using a lot of content that I found online, and I'll be continuously referring back to the textbook, which is K.A. Stroud's Engineering Mathematics, which I'll put a link to in the description below. So we're going to start off here. I have a little camera over here that can assist me for when I'm writing on the paper, and you can take a look at it. So we'll bounce over there now. So, engineering mathematics. Starting with polynomials, going into linear equations to begin with. Okay, so linear equations. Now, linear equations have a general form. Whether you're associated with algebra or not, I'll be able to explain this to you in layman's terms. So linear equations always take the form of ax plus b. Now, I've wrote that in green just to show you here. So in this case, our a term is a multiplier of x. That can be an integer or a fraction, so it could be a half a, 1a, 2a, 3a, 18a, anything like that. And b is our integer or our term. So b can take the form of a whole number. Okay, so a is our multiplier of x and b is our integer or our term. So examples of this: 3x plus 2, where our 3 is our multiplier and our 2 is our integer. In this case, it's a full number. So I can also have say 3x plus b, where b in this case is an actual term by itself, and this can be solved using a thing called a simultaneous equation. So some examples of linear equations right down below here. So it doesn't just always have to be x, it can be realistically any term at all. So let's take a look here. So it could be something like 3i minus 7. It could be, if we wanted to use negative numbers to make it a little bit different, it could be something like minus 2x plus 3. Usually when we're solving equations like this, they have to be equal to either 0 or equal to a number. So I'll just do the same examples here above and do them, make them equal to 0 and solve them that way. So we have 3i minus 7 equals 0, and we have minus 2x plus 3 equals 0. Now let's focus in on that a bit. Okay, right. Now, what we have to do in order to solve these linear equations is we need to take our integers in the equation over to the other side. Now, when you take an integer from one side of the equation over to the other, you're going to swap its sign. So here we have a negative 7. If we take it over here, we're going to get a positive 7. Now the reason we do this is we want to we want to make I a thing called the subject of the formula. So we want to solve for I, we want to know what I is in this case and what X is in this case. So again here, 3I is equal to 7. Now in order to solve for I, we can just take that 3 away, divide 3I by 3 gives us I, and we can divide this side by 3 in order to get that answer. So whatever we divide the left hand side of the equation by, we must reciprocate and do the same on the other side. So 3I divided by 3 is I, and then we have 7 over 3, which can be left that way or could be put into a decimal if need be by typing it into your calculator and figuring out what that is. That's a bad way of writing 3. Right, 3 like that. Okay, so for our other equation here, we will do exactly the same. So minus 2x equals minus 3. Now a good way to solve equations when you have a minus term as a subject of the formula, I usually find, is to, as opposed to moving the integer over to the other side, I would actually move the term to the other side to make it positive. So if we ignore what I've just written here, I will explain to you now. So ignore what I've written there. So instead of taking the 3 over, what I did there, take the minus 2 over and make it positive. It makes it a lot easier to solve. So we have 2x is equal to 3, and then it's exactly the same principle as over here to the left side. We have x is equal to 3 over 2, and that's how we solve them.